So what is coming is directory. Okay, and I should say the directory, in some sense, okay, is as important as your data. Okay, so this is we can trace back to the previous questions that I just asked. Okay, you know there is a file, and the file contains an ISO file, maybe it's your game, your installer, I don't know what is that, but you can find the file in there. Okay, so where actually the file name or other things like the size, okay, where is the size? Of course, every file system won't do this. I don't know the size, okay? I open the file as a read-only mode and then scan it byte by byte and count how many bytes there and what is the size. No, never. Okay? It won't happen in that way. Okay? Except once. Okay? Sometimes you will find some experience like that. Okay? You go to a window. What is that guy called? Finder for Windows. Oh, File Explorer. Okay? Yeah, somebody forget about it. I didn't use Windows for so long. Okay? The file is small. Okay, you open it and right click over a file, and immediately it gives you the file size. Okay? Did you have any experience that you want to query some size? It needs to count, and it needs to scan something. Okay, it gives you a not instant response over the size. Do you have this kind of experience? If not, I think that you didn't use anything to do it. Okay? Or you don't use ask this, I just ran. Yeah, I never sit down and do it. Okay. Any ideas? Any experience over this? You open up the File Explorer, you right click over a simple file, it gives you a file size instantly. How about directory? Okay, right click over the directory, you want to ask for the file size, not file size, storage on this. Okay? Then it takes some time, you can try it out, okay? I don't know whether this is cached on a HFS Plus, okay? But I'm very certain that for NDFS, FAT32, Linux, Extend 4, they all behave like that. Okay? So let's take a look at what exactly a directory is. Okay? So the directory is actually I would say a bunch of this record. Okay? So what is this record? Usually we don't call it this record data. We call it metadata. Metadata means you open up a JPEG, and the JPEG contains some information about that file, when you take it, what camera you're using. We call it metadata of a JPEG file. And the metadata of a file, you can always write it to a file and see it. Okay? I surrender. I surrender to this guy. Okay, I open it up. Yeah, someone laughed, then you know what I'm going to turn on. Yeah, of course, this is a valid license, okay? Yeah, this license is coming from our department. Okay, just wait for some moment. Okay, oh, so fast, okay? Yeah, this sucks. I should change it into another sound, okay? Yeah, I should change it, or something like that. Okay, just wait a moment, okay? And this record is actually a very important information you can say, right? You name a file, okay? Without the name, you can find the file, right? It is kind of unique. What does it mean, kind of unique? It is unique, or you are this, right? Or you guess or not. It's not, right? It's only unique over your directory, okay? The name. It's not unique over the entire list, okay? I created a file called A.C, okay? And created all over our hard disk in every directory, but within that directory, it is unique, okay? The file size, okay? So we store this file size. Permission and ownership, okay? So what is ownership? Means who owns that file. Okay? Permission, you already know it, whether it's executable, readable, or writable. I highlighted this box because not every file system implement that. Okay? At least your USB drive don't have it. Yeah. If the USB drive have it, that's good, right? I lend my USB drive to you, you can open up a file, right? But that's not the case now. Except you include the USB drive, right? You lend your friend your USB drive, and usually you tell your friend, yeah, don't open that directory. There's a dark secret there, okay? Yeah, really dark, or guy, right? Okay, so this is the ownership which is missing in every directory, and your USB drive is using that. How about others? NDFS, extend 234. Okay, extend 234 means version. Okay, and now we are using extend 4 in Linux. Okay, it's quite a years already, close to 10 years already. Okay, for extend 4. Okay, the next version, there's no next version coming. I guess the community will eventually change to the OptaFS, which is the B3 file system. Okay. Then what is it? This is what we call a directory entry, or someone call it just a metadata entry. Okay. And that entry, where can you find it? You cannot find it, right? If you type open, right? Open the file, no, you cannot find it. But you can always find it through LS. Okay. So, yeah, here I got this little bad guy. Okay. So I zoom it in. So what I'm talking about is about the information. Okay, is when I right click it. Okay, you see something here. Well, I just asked you whether you have experienced it. It's keep counting. Okay, I mean this size. Okay, whenever you right click over a directory, the size doesn't mean the directory itself. It means the thing under the directory. Okay, so it has to do a DFS, I don't know DFS or BFS, but exhaustive search over the entire directory tree and aggregate all the file size of the fortune tree. So it takes some time, okay? But usually for normal file, whether I have a normal file here, oh, I have a PPT, okay? Normal file, okay? So you can see a bunch of data here. Oh, but I have to make sure one thing. What is the file system here? Let me make sure the file system first. C drive, copy this. NTFS, good. Okay. So whenever you get an NTFS, okay, so this is a basic, I should say there's some common characteristic here. The file size, the modification time, access time, create time, so on and so forth. There's a very interesting job, okay? Now you're doing the demonstration, right? Some people, some bad guys, I say bad guys, okay. Let me tell you a story. Sorry, it's like that. He come to me and say that I submit something to my system. And this is not happening this year, already 5 or 6 years ago, okay? We're not using the web system, okay? He tell me that he submitted, but the system don't give his response, okay? So definitely it's a lie, okay? Then I tell him, okay, you give me your own laptop and let me take a look at the laptop to see the timestamp, whether it is created or modified after the deadline or before the deadline. If you know the deadline, okay, I give you I show mercy, okay, and let you treat it as a bad submission. Then it comes to me with this 3 entries. Okay? The interesting part is, I don't know what software he is doing to change the timestamp, but he showed this 3 entry, I will say, no, 0 marks. What is that? The modification time is more earlier than the creation time. With that kind of brain, how come he can get to university? Yeah, so did I go to some scenario that guy is a time traveler, or is even more? I mean, the more reason. How come, right? Of course, he used the software to change the modification only, okay, but not the creation time. Yeah, interesting, huh? I mean, that guy would have failed this course, right? Very simple thing. Work failed. Okay, so we want to treat me, okay? Don't consider me as an idiot. Okay, so well, this kind of things, okay, it's all happened in a file system, but there are many, not many, an option that allows you to forget about those up there. Okay, so just a little information for you guys. Do you know what is access time? Do you know what is access time? How many of you have heard of this thing called access time? I think for Mac people, maybe you have seen this, okay? Where is this? Let me go to my desktop. So let's say this is my desktop. I find a clean area to right click, okay? Wait a moment, move out a clean area first. Okay, right click, sort by. Okay, so we can sort the desktop, okay? So you can find date, created data, well, there's the difference here. Date and created is not the same day, okay? A day modified, so now this, whenever I have a latest update, my latest file will go to this position. Okay, it will pop up in this position. And there is one more thing called last open. That is the access time. Whenever it access the file, it will update the access time. And what is the meaning of access time update? It means that it really go to this metadata. I never tell you where the metadata is, okay? Just imagine in the database, you will find this metadata box and open it up. Just because you double click that file, you will update the access time. Okay? So there is a bunch of people think that this is not very efficient. Not very efficient in the sense that whenever you, I just read only, okay, come on, why you, read only means read only, right? It's reading this. But eventually it becomes updating this. Because you have to update access time. So there is an option in many file systems which we call it, come on, okay, which we call it no A time, okay? No A time and no A time attributes there. When you are trying to access the file system, before you do it, today's tutorial will teach you that command. It's called mount. Okay, when you mount the file system onto your hosting file system, you can say that no A time. Means that whenever I try to read the disk, don't modify the disk for me. And there is a study usually over a server scenario or even your home NAS, okay? Really fast, okay? If you forget about this update, you just treat the disk as read only, it will give you a very instant response, okay? And of course, save the disk life, okay? And the thing about it is, if it's a mechanical disk, still okay. If it's using SSD, yeah, you think about it. Do you know that when SSD, we're talking about SSD, there is a write count and read count, right? Whenever you write more, there the counter you can change as a folder. The folder will become fewer and fewer. When the folder for writes go to 0, that particular area in SSD will, I would say, gone, die. Die means that you cannot write again. You know that? How many of you know it? Only you are not from CSCI. Come on, CSCI guy, come on, yeah. Read more magazine, please, okay? Yeah, I just read it from when SSD getting more favorites among people who buy a computer, they already know it, okay? So I always say that, yeah, it depends on your budget, depends on your cycle in updating your computer. If you update your computer very frequently, doesn't matter. Yeah, eventually you will fall away your SSD. Okay, but you use the SSD on your NAS, on your file server, I will only say good luck to you. Yeah. You mean what is write count nowadays? They have some way to protect that folder, but I remember it's only a 5-digit number, not very bad. Okay, so keep in your mind that SSD is not that safe. Okay, that's why this computer is not bought by me. It's bought by my department. Okay, I don't care. Yeah, damage the SSD, no problem. Yeah, just it's died. Come on, replace it. Yeah, so think about it. So mechanical disk still okay, no problem. Okay, mechanical disk, if we have another problem, capacitor. Okay. Yeah, no one knows it. You guys are CS major. Come on, that guy is not CS major. Oh yeah. Okay. I go to the wrong place. Now, where is this box is? This box is actually hiding somewhere. Okay. By the way, I can teach you how to access that particular box. You know, in Windows, it's just right click on the file. But in Linux, there is not just Linux, a Mac is also support this call. There's a command as well as a same system call name. The command is called STAT. You can call it a statistic or metadata reading, something like that. You can read the statistic of that particular file. Okay. So Let's try two files. Okay. So I have a make file here, STAT make file. Wow, ugly, yeah. First of all, this is a Linux version. Okay. So in Mac it's still the same thing. Okay, but without the explanation. Okay. So maybe I go to a Linux to show you. Okay. Linux. Hey, come on. Okay, so STAT, maybe I go to root directory first. So you can see that it's reported as a directory. Okay, the block size, later on we will talk about what is block size. The block size of the file system is 4K. The access time, modification time, change time, okay, all are there. Some of the things later on we will talk about it. Let's say what is that? I know is for elite class, okay. I don't have so much time to talk about it. What is I know? What is this? Accessible node, you know it, okay? So the GID, UID later on, when we have time, I'll talk about this ID. This ID is quite important in accessing a file. Okay, so let me show you one more thing. Let's create an empty file. So to create an empty file, I just touch it. Empty.txt, STAT, empty. Okay? So it's totally different, right? Of course, the difference comes from here, from directly to a file that's trivial. Okay, but it's also telling you that it's an empty file, size is 0. Why is the question mark supposed to be double pro? Okay, you know, I cannot display those so smart pro. Okay, I don't know why it's smart. It's stupid pro. Because of the question mark. Or there's a here, or there's a verb as well. All right, so this is the statistic, and oh, I forgot about this. There is a system call. Okay, you can implement your program. You give me a file path. Remember, it's path. You give me a path, then I can look up that path and create that statistic buffer here for you. I don't mean create. Okay, it's return it as a pass by reference. Okay, you create it and you can read it. And for directory, it's actually the host of this kind of boxes. Okay, and these boxes. Now I tell you the hosting place is directory, but you never be able to use text editor to update a directory, right? Yeah, how many of you have tried to use an editor to open a directory? Who are using VI? No? Well, Jason, Jason, you should use it. Using VI. Oh, yeah, don't pretend I cannot see. Okay? Using VI, right? Yeah, use VI to open a directory. What can you see? Yeah, I have to do the same as well. Okay. No one using VI? Come on. VIM slash. Oh, yeah. No? Nothing? I've got nothing because it's not VIM, okay? I need to install VIM, but maybe I go to the department. Department Linux should have a VIM. Yeah. So it becomes something like this, okay? Now, don't argue with me, okay? I tell you the truth. The truth is, VIM cannot edit it, first of all. You can try DD, okay? Less DD etc, okay? Well, how many of you know what DD is? Yeah, if you don't know, it's DD line, okay? Yeah, let's try DD etc, okay? Can I DD etc? DD. No, let's just go crazy. Give a directory name or something like that. Okay. So first of all, the truth is VIM is using the STAT system call to read through the entire directory. Keep picking up this information and show all the information here. It's just display, not really editing. Okay. So where are the ways that we can update this guy, okay? Name, size, permission, okay? I can open a directory, and what's the meaning of open directory? What is it? It means nothing, okay? Because you can take a look here. Whenever I want to change something inside the directory, we're not working with the directory, but working with is host file, host file. File hosted in that directory. Okay, we can change the name through this code, this command, mv. Okay, or you cp means to create a directory entry or directory files. Okay, I mean a file or directory file. Okay, and there is a system call for it, called rename. Okay, and size, too many things. Okay, you can open up the file and change it, and whenever you save it, the directory will get updated in a synchronous way. Okay, so I can try together with you guys. Okay, so this is my account. I go to the temp directory. The temp directory is a public place that I can do whatever things there. I create a directory for ty1. Okay, yeah. Hope that some people want to go in and take a look. Okay, because it's a public computer. Okay, so what I'm doing, I will do a stat dot. Okay, so you can see the creation time. It's just now, right? I'm in ISS on creation time. It's just become empty. The change time, whatever time is all just now. Now I will create a file. Okay, create a file. Cat a.txt hello world. Okay, so I just create a file. Create a file a.txt. Okay, and let's see stat dot. Can you see whether it's updated or not? Compared to the version I create a file. Before it, after it, it's changed. Okay, whenever you change, you create a file, okay, it will change. Or even I do this thing. Okay, stat, this current directory, rmn. Okay. So you see, it's changed. It's just changed. Okay, and because you are changing the directory, and the directory is hosting this kind of attributes of each file. Okay, later on I will show you the layout of this guys, where is it hiding in the directory, and the permission. You know that there's a change mode. You can change ownership. Okay, from one user to another user. What is the meaning of from user to another user? It means that always on the root to another guy. Okay, you cannot say that, I know that there is a kind of TY wall, okay? I get a hold of that file, but I am not that user. I change mode to become my file, okay? No, change mode is not this permission. Change own, also no, you can change ownership if you're not the roots, okay? And the modification time, creation time, access time can also be updated, okay? By the command called touch. Okay, so I'm opening up the Pandora box. Okay, so take a look at the touch command. There is an option called -d. Okay, pass the string and use it instead of current time. What does that mean? I create a file first. Touch stat a.txt. So it's just now. It's just now. Okay. So how about I touch this again, but -d is it equal? I can't remember. -d. -d is not equal. Okay. So touch it. -d. Double pro. What is how about 1 year before? 11.5. I don't know whether this format works or not. Let's try. Okay, so the current directory, this is an update. I don't know, but how about this guy? Yeah! Now, I teach you this. That means that from now on, I don't trust any timestamp again. I don't trust. Is it simple? Yeah, very simple, right? See? Powerful, huh? Just a little command, okay? You touch it, give it a date, okay? You can create a 1997 or even a yeah. Woo, yeah. No problem. It's just, this is just data, right? It's data, we can change it. Yeah. dangerous call. That's why I said it is a Pandora box. Okay, I'm actually hurting other courses. Okay, other courses. Oh, okay, I believe in you. Okay, but they don't let you already know how to change it. Okay. Oh, by the way, where I'm working on Linux on our department machines. Okay, so that means that. Every Linux should behave like this, okay? Not just my Mac machines or my own VM. I just use a public computer. Yeah, dangerous, huh? For me, it's very dangerous, okay? For you guys, you will say, oh, very handy, okay? Yeah, you help your other majors friend. I mean, none of my business. All right. So I fast forward a bit. Later on, we will revisit this picture. Fast forward a bit. Okay, so what is the layout of this kind of file attributes? Because I talk about file attributes, I don't want to stay away from this topic. Okay, so inside a directory is actually using this layout. So what is this layout? An array. A directory is an array. Okay, so for the file system, you are allocating space for a directory, and every file system, I mean really every file system, treat this guys as an entry for a specific file. So what we will expect is like this. You're expecting in the beginning, you have an empty directory. Okay, so you have an empty directory. Then you create a new file called a.txt. So what that directory becomes will become, okay, a whole chunk of things, okay? And this chunk of things, why I draw 4 guys, okay? It's just of course a random number, but also because of this allocation. Later on I will tell you about this allocation. Whenever you ask this for data, it will, let's say you want a byte, they will give you a byte. They give you more than 1 byte, okay? So let's say that this gives you that area, let's say is a 1K, okay? And when you create this a.txt, every entry of the a.txt will go to one of the slots. I create b.txt, c.txt, and so on and so forth. Okay? So there are several problems that you should look into through this illustration. First of all, will I have a problem that I use up all the space in the directory? Yes, you will. Because let's say in my application here, that this only gives me 4 blocks. Okay, let's say I go to d.txt, I use up all the space. So what should the system do? You never say that, oh, run out of this cannot create a file. No, you never say this. It will create another chunk of data to host it. And later on, we will go into this layout to see how to concatenate all this chunk together. Okay? So let's forget about the full problem. Let's get rid of it. Another problem. Now you are going to have this layout, okay? Is there any sorting? We don't know, right? Because I illustrated this example just using a sorted list, okay? I can tell you that when you are doing the assignment 2, you will understand that inside this layout, you can access this array by doing assignment 2. You will find that there is no sorting. No sorting. You say that you create a file, this is the first order, first file to create, this is the second, this is the third, this is the fourth, okay? It just follows the order, but I so happen to treat you guys right now a.txt, b.txt, c.txt, okay? So ls is doing something. ls, when it finds this all 4 files, it do the sorting for you on the memory. Okay, so on this, it is all follow the order that you create. So there is no sorting, but the order of creation. Okay, it's follow another pattern. But I put a question mark there. So what is exactly means the order of creation? Order of creation is doesn't rely on the system clock. Okay, and let's say I change the system clock to another time, we will change. No, it's the meaning that it create that guy, and that guy will be there forever until you delete it. So what is the meaning of delete? File deletion. Okay? So here you cannot see the data. I hide it somewhere. Okay? But when you delete the file, you will delete all the data as well as delete let's say b.txt, I should delete the b.txt, I should erase all the metadata or the attributes that belong to b.txt. Okay? So this is the time that we will update the directory again. What is the meaning of deleting? That is it. I don't remove any data, I just modify it, I just color it in black, okay? And that is deletion. And what we usually call this, what is the name of it? We usually call it lazy deletion. How lazy it is? I just said that, okay, I drop it out, okay? No one can see it's called b.txt anymore, okay? And I don't even move this guy. I don't do it. I just keep the dead record there, okay? And this is deletion, and that's why we call it lazy. Really lazy, okay? And every file system is doing this. Every file system. I never seen a file system don't do this. Okay? Why? Because it's fast, right? It's really fast. You can do a measurement. The measurement, I tell you how to do it. Okay? You open up a file, create approximately, don't create too much. Approximately 30,000. Okay? Create 30,000 files. Use a loop, okay? You can use a loop call system, create it, okay? You try to create this 3,000 file, okay? And also try to delete it, okay? Of course, when you create it, you should give some data there, don't create any file, okay? You can compare the time that you spend on the creation in much bigger than the time you spend on deletion. I think you should have this experience, okay? You'll find that, oh, I install again, okay? Then I find that I don't like that again, and again sucks, okay? I will delete it. Do you need the same amount of time for deletion as the same as creation? To install it take much longer time, but deletion, boom, gone. Yeah. Why? Because deletion is put a pause there. That's why it is so fast. And did I say anything about data block? No. The data block is usually still in this. We just change the directory. Okay? Wow, very interesting. Huh? The interesting point is, that means that I will make a claim. Okay? Later on, I will break this claim. The claim is, whenever I delete a file, I can always recover it. I just delete the record here, right? That means the data blocks, okay, I create a file which is 4K size, and the 4K data should be in this. I don't care about the data, when the data there, okay? And I put a claim here first. Later on, I will break this claim because we have some technical hurdles there. It's not easy to overcome, okay? And we will go back to this page, okay, to talk about what exactly is metadata allocation, not just allocation, reading, writing, updates in the kernel. Okay, so why not, it's still early, I think I should give a break, okay? Yeah, let's go to talk about this. What is this data flow? You see this before, right? When I talk about open system call, okay? The open system call, you open it, some operations going on, go to the query of this, and this say that, okay, I found a file, give me the file, and now, previous thing, I never say what are the things that the disk will give you, okay? The disk may not give you the data, right? You can try. You can write a 4 GB file. Actually, you don't need to spend the time to read all 4 GB, and immediately you write it and see its properties, it gives you the data instantly. Why? Because it's just bring out the file attributes of that specific file. Okay? Whenever you try to open it, it never touches the data block. Okay? That's why open is very fast. Okay? No matter, it's independent of the data size. Okay? So what really going to return on the disk is just all the attributes, file name, the size, what else? Creation time, modification time, and other specific to that file systems. Okay? And this is open. And actually, open do something more. What is the thing that is do something more? It is a set of runtime attributes. Those attributes is not static, not permanent. you don't go back to this. Okay? So you query something, we have a purple guy here. The purple guy is something that, let's say you update it, it will eventually go back to this. Let's say you open up the file, you add some file to it, and one of the attributes is this size, on this size. So when you open it up, you do some change, you will need to update that size. Now this green box, green set of attributes, actually the attributes that you don't need to write back to this. Okay? They are something that you may not familiar with. Seek, the file seek. Okay? Last time I talked about FC. FC code. You can position you're currently starting from first byte. Okay, then you can call FC to reposition that. Some people call it a file pointer. I mean, I don't give it that low level. Low level is, I mean, not low level. It means that there's a sub name. Okay. How is file pointer? This is called sync. Okay, the file sync. You open it and the file pointer. Okay, I need to use cheap language for you guys. Okay, got it. File sync is the same as file pointer. It's a number of bytes. Okay, usually a number of bytes from the head of the file to there. And do you need to write it to this to tell us this that that guy opened that file at position 1, 2, 3, 4. Okay, you don't need to, right? It's always specific to your process. Yeah, even for your process only. For other processes, they don't need to know you are reading 1, 2, 3, 4. It's just for your process. So when you open it, it will create a set of memory on the kernel to store this location that you're currently updating, as well as the opening mode. Okay, a file don't care about the opening mode that you want to open. You open it as read only, write only. I don't care. Okay, when you read it, I give you 4 the file attributes, and that's my job. Your job is also give a parameter there in open or app open, and you say that whether I do a read only or write only. Of course, when you write to a file, there will be more trouble work there. Let's say open it with app open, double quote W. Then what will it behave? It's not just reading the file attribute, right? When you do this and it successfully say that I can open it, we will truncate the file. What is truncate? Yeah, you never heard of this, or you heard of it, but you don't know it. Truncate. Truncation. Man, truncate. There is a command called truncate, and it's work with files. Okay? And this system call is also called truncate. And truncate system call and the truncate command is only doing one job: change file size. Okay? Whenever you use fopen, double quote W, you will truncate the file size to 0 if you have the permission to change the file size. Okay? So this is truncate system call, very beautiful call. Let me try that. Yeah, I really love to try this because this is interesting. Let me check. This department hard disk. Okay, it's just 5%. Okay. It has available disk space 8.4 GB. Do you think I care? 8.txt. Now 8.txt doesn't exist. Okay. So I forgot about the specific size. Okay, specify the size. Oh, let me show how long it is. Originally it's 0. Okay. Truncate size. Let's try 10 bytes. Okay. Then you know what I'm doing next. Yeah. Don't do it. People won't kill me. Truncate system call. Okay? But do you find it strange? Do you? You take it for granted? What is the size that I just created? How many men? I can't count. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow! Huge, huh? create that fast. Less than 1 second. And let's say if I do this command over the FAT32 USB drive, it will happen in another manner. It takes quite a long time, and then lastly we push you that usually we call a file system has no space or space, something like that. Okay? But now you will find that take any time, right? Because what? Because this is because of the order command that I just take a look before I do this action. Okay? So let's see the. Can I take a look at the root file system? It's too many entries here. Root file system. Help me to look at the root file system. The root file system characteristic is only one slash. Okay, so many slash here. Where are you? Can you see it? Yeah, I see many slash. You see it? Where? Yeah, you know my eye is not good, huh? I cannot find it. 你睇到啊？我睇唔到。我得。Where? Where? 邊行啊？BDD? Temp file system 下邊嗰個。I cannot see it. 你出嚟話我聽喺邊啊？ Where? This one? Below it? Oh, here. Okay. Oh, you see this? I'm getting old. Okay. Yeah, 20 years later, you guys will become something like this. Okay. Yeah, why I highlight this line? Okay, take a look at here. Extend for. Okay. So some file system is behaving something really strange. Okay. Behave really strange. Extend 4 is having a special thing, just like you guys, okay? I asked you for some this. You promised me to give me this space. And when they fulfill your promise, we don't know. Yeah, I just said, oh, give me 10 GB. Okay, I give you. When it fulfill the promise, the time that you write this, okay, it will fulfill the promise, okay? I think that this is a quite pen. I mean, you will find pen powerful Windows. This you will ask this question, right? Now, when you want to know whether a file system will behave like this, you can try the truncate system call. Okay, it will give you some promise, and the promise may not be fulfilled. Okay, and here is an example. You can try in Windows. You can try, but try is always. Okay? Windows may not behave like this. And whenever you create a VM, okay, how many of you have created your own VM? If you create your own VM, you will be asked one question. The one question is to ask you whether you want to grow the disk now. Anyone see this? Or you don't know what I'm talking about? Yeah, you create a VM, okay? Using a VMware VirtualBox, okay? You create that. It will ask you for this size, okay? 20 GB size, 8 GB size, okay? There is an option, okay? The option they will ask you whether you want to grow the disk, okay? So usually you don't care, okay? You don't care. Now I give you what it will behave, okay? If you answer, you want to grow the disk. So that means that I don't want to expand for file system or a specific file system to give me some hollow promise. Fulfill that means. Okay? Grow the disk, grow the file size, as well as keep in the storage. And if you choose not growing the disk, that's it. Just like the example that I do the truncation. Okay? Yeah, the example I do a truncation, I truncate, and it just say that, okay, I give you you create a VM of 1 TB, yeah, I create a 1 TB for you, but I never fulfill my promise. Okay? And why I have to tell you this, okay? Because it's just for your future. Whenever you create a file using this truncate command, you want to transfer this file to another file system, and that file system don't know. You are just picking up. picking up this number in your wholesale file system, what will it do when you do it in copy? It really tries to find, in this station, do I have this size? Actually, it will become a disaster. You can try, okay? I will give you a clear step, okay? But make sure that it is your computer. Okay? Don't ask me, hey, can I do the experiment on your computer, on my computer here? No, okay? Use your own, okay? I give you some recommendation, use Windows. Yeah.
What if now you write something to make them?
Very good questions. I don't want to open it because when I open it, it will show the content, okay? I can give you some idea. The idea is actually break this long file into boxes, fixed size boxes, we call blocks. You change this block, it will create that block. So let's say I create one byte in the leading part of the file. That part will be created when maybe a 4K, create 4K data, but remaining still not in this. Okay, so this is for the sake of performance. Okay, or you really want to fulfill the promise, you touch the file, you create the whole trunk, it will become very small. Okay, so extendable behaves something like this. You can test a file system, truncate 1 GB, whether it's finished within 1 second or within 1 day. Yeah, you try. 1 GB may not 1 day, okay? 1 GB is 10 minutes. Less than 10 minutes if you're using USB free. Okay, so well, file system is quite an interesting thing because you can really try it out. Now here is about the kernel, open it up, and the kernel open it up, read the thing here, create the runtime attributes. When you do some changes like you want to reposition it, call it fseek, then you will change this area. You want to create some extra data, append new data to it, it will change this fixed attributes, write it back to the list as well as change the runtime attributes. Okay? So let's take a look at what is the read system call. Okay? So the read system call, when you play with this guy, I said that there is a runtime attributes to pointing to the location that you currently reading. Okay? So that's why the read of the reading, you will change the runtime attributes. And remember, this runtime attributes, there is no arrows pointing to the hard disk, so it won't go back to the disk. Let's say you try to read it now, you start with the first byte, and the file system attributes will also help because it will want to check whether you reach the end of the file. Okay? Here is a contain the file size, so you can always use the file size to compare with this runtime attributes whether you reach the end or not. Okay? So when you reach the end, then the read system call will tell you, oh, I cannot proceed anymore. Okay? Now let's say it can proceed. And wherever it can proceed, it will go to the hard disk to really take out that file. So that's why I said that open system call won't give you the data right away. It will depend on your read system call. You ask for that 1K, I will go to this, give you the 1K, and return that 1K to your read system call with some more, with something more. And the thing that is more, we call it kernel cache. Okay, there is a small buffer, not big. Okay, but it will change in size when, let's say, the system is running out of memory, so the cache will be smaller. The system is full of memory. I mean, plenty of memory, enough memory. Then cache will become bigger. And the cache is for you to, let's say, you want to keep reading that specific block again and again and again. Then you don't need to access the disk so frequently. Okay? I don't know whether you have this experience. The experience is you want to open up a file or open up a directory, you read the directory. For the first time, it's very slow. Then you read the same directory again, it will become very fast. Okay? Because those data already go to the cache of the kernel. Okay? This is called a read cache, and we also have write cache. What is the write cache? If you have the write system call, okay, when you go to write it, it will go through the cache to see that whether the cache contains the data. Let's say you just read a block from the hard disk, so the hard disk should have that block, and also the kernel's cache also have that block. Then you try to write it, it will first update the cache, change the file attributes because you write something, change the runtime attribute as well because when you write it, the file pointer or file C will change. Now, what is the consequence next? The next is return. Immediately return. Okay? And take a look here. Is return, then write into this. It seems to be strange, right? It should be something like this. I update the cache, I update the cache containing that trunk of data, I update it, then you should write the this. And after writing this, tell the write system call that I finished. But all operating systems do it in the reverse way. You update the cache, the first step update the cache, update the attributes, then return. Tell the write system call that I finished. Then I don't know when, actually there is a time limit. For some time later, it will find the fourth step. The fourth step is, inside the cache, I have that data block. Now it's time that to write back to the hard disk. Do you find any problem about this? If you don't find that it's problematic, I will give you two problems. The two problems is, there's two. Not the beginning two, but the later two. The later two problem. Let's say you accept that, okay, Windows although it starts to implement that way, Linux also implement that way, Mac also implement that way. Now I ask you the question, can I press the reset button on your computer? Or is it safe? Or is it safe that let's say this computer, why is computer? Because I can remove this factory. Okay. I just ask people to push it on the share, I steal this computer, immediately pull out its battery. Is it safe to do so? Of course it's not safe for me. Okay, you try to do this. Okay? Is it safe? Any questions? USB drive. I don't know for you, okay, for me, I understand the working behind it. So I sometimes will pull out the USB drive without clicking the eject button. Will you do it? Will you? And the answer lies in this page. Is it safe or should you do the eject button? Okay? So I will give you a break. After the break, I will continue to talk about some storage things. Today's recommendation is also about storage. Then we will ask someone to tell me the answer. Okay? Yeah, the Facebook is keep on. From eBay, okay. Well, the previous two questions, can you reset it? Or I should say the same to reset it. Okay? So how many of you have, let's say, suddenly drop a battery or just do the power outage suddenly? Have you ever tried this? Sudden power outage? No one? Only you. So what is the consequence? Or no consequence?
Fortunately, you don't have any problems. But if you are writing something on the hard disk or the USB drive, probably
Lots.
yeah, everything is gone.
Okay, so he giving you guys all hear the answer. It depends on your activity. So if you're writing something to the disk, and suddenly you have a power outage. Okay, let's say that I forgot to take a picture. Okay, department has an very old computer around the year 2000. They buy a set of computers. I don't know who make the order. I draw it. Okay, that's why today we have pen here. Okay, they buy a computer. This is a tower. Okay, so this is a computer tower. So we still have a CD here. Okay, and let me show you how big that power button is. I draw it to scale. Okay, so it's a circle. So the logo is here. The logo of the computer is here. This half is the power button. This half is the reset button. Okay? So what is so funny about this? Many people put this computer on the ground. Okay? And let's say that when they go to the lab, okay, they do this, take a bag, put it in the floor, and then they suddenly click the bag, reset. Okay? Well, there is also some others. Oh yeah. Oh, that's why you don't know what I'm drawing. Okay, sorry. Yeah, this one. Okay. So half of it is a power button, half of it is a reset button. I forgot to take a picture. All right. That computer, I I tell I mean that system admin, hey, don't give it to me, okay? I want a cheaper one, okay? Yeah, it's very, I mean, really sucks, huh? So yeah, there's also other interesting things. It should be something that you have seen. Iron Man USB drive. No one know what I'm talking about? Iron Man USB. No, not this. No? No? You never see there's a USB drive is like this. The Iron Man is doing this, okay? And when you plug this in, so Iron Man will push the power to the front. You see this? Yeah, oh yeah. I don't know who decided, okay? So, oh yeah, you never know. Okay. So again, well, the certain power off, okay, will definitely hurt you, okay, because while you're writing the file, actually the data is in the cache, not to the disk, okay? So that's why you will lose the data that you try to update in the cache. Really horrible. Yeah. How about USB? Can you eject or you don't eject? Yeah, sometimes I don't eject it because I read only from the USB drive. I know that I want to copy something from the USB drive to my host computer. Okay, I want to copy it to my hard disk, and after I copy it, I pull out the USB drive. That's okay. But in the reverse, if you are copying from some file from the host to the USB drive, it said it's finished, but actually it's not. It's actually still a part of the file in the cache, and they put it out without any awareness about this problem, then you will lose that file. Okay? I really have a experience. Okay, the experience like this. Okay, several years ago, maybe more than 5 years ago. Okay, there is a group of students also taking 350. Okay, they want to ask me questions. Okay, so they try to copy the source code to a USB drive and use USB drive to go to my office and ask me, hey, why is that? Okay. Every time they come, the file is not there. Okay? I say that, the first question is, are you using a computer? They said, yes, I use a computer to copy. So of course, these are stupid questions, okay? Another question is, I ask, what is your USB drive that you're using, location, is they tell me that they're using Linux. Now, why I ask which machine they're using, and actually this write cache support can turn on or off by the time that you insert the USB drive. In old Linux, they will, how old it is, approximately 6 or 7 years, okay? When you plug in that USB drive, it will enable this cache for that USB drive, or a file for that USB drive. And in Windows already know this problem because Windows sucks, it will suddenly crash, okay? And Windows know that the cache support is not that good, okay? Because itself is not stable. Understand what I mean? The reason there is a built-in power cut, okay? The built-in power cut support in Windows, okay? So they know about this. When you use Windows, you copy something to USB drive, it is very slow. It's very slow because it don't write to the cache. They directly write to the disk. Okay? Because they know they have their own problem. They have own problem. So this is the point, okay? And that's why I asked, when I know that he is using Windows, then I know that it's because they forgot to press the eject button and pull it out. And in Windows world, it won't happen. Right? Because it will take it very slow and then save it and eject it. So that's why nowadays, when let's say you're using Windows 10, Windows 7, when you press the eject button, it will just take a little time so that they want to check whether there's something still in the cache, something didn't flush the disk, and very little time it will eject, finish, and then say remove the files. And in Linux, okay, if you are using old Linux, then it will take some time. You say eject, it will hold it there, right. They don't show the progress bar, okay? They will tell you that said, don't eject now, I'm doing something important, then it said eject. Because this is the time that they flush the memory things into the USB drive. Okay? Yeah, so this is a very interesting point. All right, so, sorry. I should go back to the slides here. Oh yeah, did I start the recording? Huh? 哎呀，哎呀，哎呀，有冇 start 啊？有啊。Oh yeah, 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 Scare me. Yeah, I don't know whether I'm getting old or not. Okay, I'm older. I'm 1 month older than previous month. Okay, so I got a problem. Okay, so why do we have this support, right? It seems that this support gives you questions, gives you problems, gives you a data loss. Why it still exists? It's not removed from every kernel. Every kernel like your phone is also behaving like that. It's because of the promise. Actually, it's because it can increase the writing speed to give you false image that we are doing something very fast. Writing speed is one thing. Reading speed, when you read something again, and again, it won't take a long time. Okay? So they are here to stay. They won't be removed. This support, but they will give you something better, like they know that it's a USB drive. Immediately we shut down the cache for that file. Okay, and this is something that we can do. For the power, sorry, we cannot do it because unless we remove that cache totally. If you know how to control this cache support, no, this is source code for year 1 elite. Okay. You can take a look at this command, mount the system, mount the file system, and I'm doing a search. Okay, I'm searching for the keyword called synchronous writing, synchronous reading, synchronous writing. Okay, so there is async support. So the async support is whenever I write it, it will write to the cache, and the reverse is sync. Okay, directory sync, directory update is sync, all IO are sync. Okay, so you can turn on this sync support. Okay, today's our tutor won't talk about the sync, but he will talk about the option for the mount system call and the mount command. Okay, so you can do the mount. Let's say I know that I'm using a system that we don't know whether it's doing a synchronous read write. Okay, then you can say that the mount option put in S, Y, and C. Okay, so there's something extra for you guys. Now, how to read a directory? Reading directory is easy. Okay, there is a full set of library support, really full set. You don't need to write to the directory because other systems will do it. Let's say you create a new file, then you update the directory. You delete the file, you update the directory. Now, how about LS? How LS can access your directory? There is a library called OpenDL. Yeah, this is like an open but without any opening mode. Because reading the directory, processing the directory, I would say, it's always read only. Okay, so it's a write to a structure here, just like the file structure. Okay, you use a pointer. So there's a directory entry, also use a pointer, and you keep on reading it, just like giving you the next. Okay, like the string token call. You can keep on reading it so that you can read the entire directory. And what are the fields inside this directory structure? Okay, we call it a den entry. Some people call it or just a den entry. This entry contains at least there's 2 important points. Okay, the first guy is a unique ID for every files in your system. So what does it mean in your system? In your file system. Okay, so you can have USB A, USB B. They both have the file number 1. Okay, but it's just unique within that file system, and this is unique. We call it item number. We put into use sign for extend 2, extend 3, extend 4. Okay, NDMS I don't know, but they try to pretend that they have a number. The name itself is just a string with a null terminator, so that means that you can print it out using a %s, printf %s. Okay, so I have a very simple example here. Very simple example. Maybe I use an atom to open it. Simple ls. Okay, just I choose the directory to open is a current directory. Okay, double pro dot is a current directory. And when I open it, you can just loop it through. I will print two guys out. The D_INO, the identification number, unique, and its name using %s. I said that this is a string with a null terminator. Okay, run. So this is how it display my my layout inside code. Okay, so the code give me all kind of strings here. I just put a tab here to tab it out, and you will see every numbers will be unique. Okay, so where will you find that there are two numbers but two files? I say two files which are not unique. I can demonstrate it now, but don't overdo it. Okay. There is a call called ln. Some people will type it wrong. I don't know why they type ls and suddenly type ln. Okay, yeah, s and n is so far away. So ln, so create a link. Okay, the link. Let's say I want to link this make file into another file. Link make file to be a abc.txt. Okay, so let's cat abc.txt. The content is like this. Cat the make file, same content. Okay? So let's take a look by using my program. Can you find make and abc.txt? Are they the same? They are the same. For the hard disk or for the file system, they are not unique. Although they carry two different names, they point to the same trunk of data. Now, what you're trying to do next, I know. How about I update abc.txt? Okay? Update txt, delete them all. Hi. Okay? Open make file. They are linked. Yeah, because there is an ID, and the ID tells you that these two guys are the same guy actually. So on the hard disk, they are the same, but in the directory, there are two entries. Okay, so what is the concept? The concept is, I should open up, I close this guy up. What is the concept? The concept is, this time I give you a new concept. The new concept is about a directory implementation. So the concept is like this. Remember this boxes? This boxes? A.C, B.C, C.C, D.C. Okay? So I say that you create a file, then you will create this directory entry. Okay? So what is that previous call? The previous call is I create a new entry. Let's say it's called x.y. Okay? And this x.y, and let's say I created through the A.C. So this guy has a storage part, and so happen that they point to the same storage part. But they have two different entries in the directory. And we use that ID to identify that these two guys are the same, they point to the same storage. Okay? So this is that concept, and the concept tells you what? Actually, a file or a directory entry, I should say, a directory entry is not one map to this space. Okay, you have this storage. Okay, can you see this? This is the relationship. It's not one map. You can have another name point to the same file, and I say that don't overdo it because this is even more interesting. What is the behavior of rmabc.txt? Will I destroy make file? Delete. ls make file, still there. Take a look. Still a high. So what is the concept? The concept is, now it's very clear that what exactly means by previously talk about delete a file. Delete file doesn't destroy its data file, it just destroys entry of the directory. Yeah, it's gone from directory. But it's not gone from the hard disk. The storage here, storage, okay, yeah, my handwriting is up there. I know it's in front, I'm misplaced. The A.C still pointed that guy. That guy still exists. But the storage on the directory side is gone. So remember, they can be totally decoupled in the sense that I'm a directory, I only manage the way to point to the data. Okay? You have another space in the hard disk for the data trunk or the data block, and they are totally independent. When you delete a file, don't touch it. Okay? I'm the data storage manager. Okay? You delete your directory entry, but don't tell me to delete my storage. That is the concept. Okay? Remember, it's totally decoupled. Any question you want to ask? This is quite new to you, okay? Because the first thing is in that our directory is so important, okay? It contains many attributes, and those attributes can be decoupled from the storage, from the data. And one more, we can ask two directory entry to point the same set of data, and we can always decouple it by using the RM, the delete, okay? And that's why usually we won't call a RM command, we don't call it delete. We have the proper name. We call it unlink. We call it unlink. Remove directory entries. It's not removing a file. I just like my drawing, I cross out that link, pointing to the data. So that's why it's called unlink. If you have experience writing PHP, you want to delete a file, the code is unlink, not delete. Yeah, okay. Yeah, really relief. Oh, that's why it's not unlink. And also there is a system call. Yeah, it's not delete system call. It's called unlink system call. It's to delete that link. It's not delete the data, delete the attributes, okay? Yeah, so after this class, you have a better idea over the directory and the files, okay? So you can become a better system mid layer, okay? You can know that, oh, this file is this or that, okay? Any questions? If no, I will proceed to the beginning of the second part. I cannot hear you. That means that you have the only entry pointing the only chunks, then you will lose track of this data.
It's like free.
Yes. Whether this is considered as free is to, this is graph theory, okay? You will check whether a specific data chunk has an in-degree 0. If you have in-degree 0, stay with it. Okay, understand what is in-degree? Yeah, if not, then I give a form. Oh, no. Someone may not take, may have skipped a data structure course, okay? Yeah, okay, I take back my claim, okay? All right, so the delete and update, so on and so forth. Yeah, quite interesting part here, right? I hope that it will increase your confidence in controlling about this, okay? So we will go to part 2. Let me switch.